In this video, we continue to explore two other options that we have to prove two triangles are congruent, and that's ASA and AAS. So notice that this time we have two angles, two pairs of angles being congruent and one pair of sides being congruent. Then we can prove the triangles are congruent. So look at the diagrams before. It says if one pair of angle, which is angle A and angle D, are congruent to each other, and one pair of sides, and the pair that's marked is AB and DE, are congruent, and then one pair of angle, a second pair of angle, which is B and angle E, are congruent. Then we can write the congruency statement. Triangle ABC is congruent to triangle DEF. So an example here, given that SQ bisects RQT, the angle RQT. So RQT is here, and that's an angle bisector there. So as soon as you read a statement, just mark it out. That way you have a visual there. And, oh, I'm sorry, RQT, and that's right. So we have to prove that these two triangles are congruent. And this one, right? So the first one is always given, and then from the first one we can draw the conclusion that RQS, which is the one on the left, RQS and TQS are congruent by definition of bisector, which is the statement here. And then it further states that it bisects RST, so that makes us draw the conclusion RSQ and TSQ, two angles, are congruent also by definition of bisector. And we know that QS is congruent to QS, and that's my mirror property. I call it mirror property. It's reflexive property. And now I have ASA to prove the two triangles are congruent. Okay. Second example here, I have two parallel lines. That's given. So let's mark it on the diagram. JK is on the left, and LM are parallel, and JL and KM are, oh, I'm sorry, wrong markers. I was thinking about congruent. Parallel lines is a little arrow, and then we use two arrows to indicate the second pair. Okay, so if they're parallel, I know JKL, which is this angle, and this JKL and MLK would be congruent because they are alternate interior angle theorem, right? So if you look at LM and JK are parallel, and KL being the transverse, so these two are alternate interior angles. And for the same reason, JLK, which is here, and MKL, they are also alternate interior angles. So by alternate interior angle theorem, they are congruent. And then KL obviously is congruent to KL, and that's reflexive property. And then finally, I've got two angles and a side sandwiched between the two angles, so it's ASA. Okay. Let's see if you can do the third one on your own. It's relatively easier by comparison. And let's move on to AAS. AAS states that if I have two pairs of angles, it's pretty much similar to ASA's, just the order is different. So now I have two pairs of angles. If you look at on the diagram, I have the angle first, being congruent from left to right, and then I have one side, BC and I think it's EF, right, being congruent to each other. And now I can make the statement that triangle ABC is congruent to triangle DEF. So look at the fourth problem here. YZ bisects angle WYX, so which means that these two must be congruent. And YWZ, which is this one, is congruent to YXZ, which is this one. So, and we're asked to prove the two triangles are congruent. So let's write down what's given first. I like to write everything down first, just so that I have everything. And then I go back to step one and start analyzing. So YZ bisects that big angle, so we can, from that we can draw the conclusion angle WYZ should be congruent with XYZ. And that's definition of angle bisector. And we also know, so look here, I've got one pairs of angle being congruent. I have a second pair of angle being congruent. And then, so I just need to look for a side. So that side is YZ is congruent to YZ. If you look in the triangle, right? So let's see if I can get a little highlighter here. Oops. Make it small. Let me get it smaller. Notice that I have one angle, one pairs of angle. I have a second pair of angle. So all I need is either WY being congruent to XY, or I can use just YZ. That way I have AAS here. So this is reflexive property, and I can draw the conclusion WYZ and triangle XYZ are congruent because of AAS. All right, so this is probably the first example we've done that you're writing your own statement. So give it a try. I'm gonna leave the other. I'll do one more. I think I'll do one more, and then you can do the other two. So here we know angle ABC. ABC is here, is congruent to CED here, and we also know that AB and CE are parallel. So C is midpoint. Right here is the midpoint, which means this segment and this segment must be congruent, right? And we're asked to prove that the two triangles are congruent. So let's write down what's given first. ABC is congruent to CED. So I already have one pairs of angle being congruent. That's nice. I have AB parallels CE, and I have C is the midpoint of AD. So all three are given. Now let's go back to the first point. Is two angles are congruent. There's not much I can do about that. I don't think so. Second point, let's go for number 3. If C is the midpoint, we already draw the conclusion earlier. AC and CD must be congruent, and that's because of definition of midpoint. So I've got my one side already, right? So I've got an angle and I got a side. I just need possibly one more angle. So let's see, because I have parallel lines, I have step 2 I haven't used. What can I do with step 2 that can help me to find another set of information? So do you see, if these two are parallel, if I extend these two lines, you'll be able to see that AD is my transverse. So, and if that's the case, these two angles should be congruent. So that because they are corresponding angles, right? So by corresponding angles theorem, which says if two lines are parallel, their BAC, their corresponding angles must be congruent, ECG. So now I've got a AAS here to prove the two triangles are congruent. ECD, I think. Or if you want to write ABC is congruent to CED, that's fine too. Okay, so finish the other two proofs. It's not too hard. Last thing is something called HL. HL stands for hypotenuse leg. This theorem states that if in a right triangle, and remember, it only applies to right triangle. In a right triangle, BC is congruent to EF, which is the hypotenuse. If the hypotenuse are congruent to each other, oops, I forgot. And one of the other two legs is congruent to each other, then you've got a pair of congruent triangles, right? It actually makes sense. Think about it. If you have the hypotenuse being the same and you have one leg being the same, and if you use Pythagorean theorem, you can calculate the third side, which is the other leg, and that has to be the same. And so in a way, this is a variation of SSS, but because it's a right triangle, that gives us an advantage. So let's see, I'm going to move this sheet upwards. Let's see if I can, I'll just put that there. Here's an easy one. The two triangles are right triangles. So ML is congruent to MN, and we're asked to prove that two triangles are congruent. This is fairly easy, right? The first two are given, and then MP is congruent to MP, which is here, and that's by reflexive property. And therefore, by HL, the two triangles are congruent. I'm going to leave you with the last one for you to finish, and I will see you in class. Bye, guys.